This PowerPoint is going to focus on just there's two types of bonds that we're going to talk about, ionic and covalent. This one is going to focus specifically on ionic bonds. Atoms can gain or lose electrons to meet stability. And that's what we talked about. The whole point of bonding is to gain that atomic stability, to gain that full outer shell. And so sometimes bonding occurs when atoms gain or lose electrons, when there's a transfer of electrons that are taking place. An ion, and this is going to be important to know, an ion is a charged particle because it now has either more or fewer electrons than protons. So an ion is created when there is more or fewer electrons than protons. Just to recap, electrons are negative, protons are positive. And remember, electrons are on the outside. They're in the cloud that are rotating around the nucleus, and so they're on the outside. Always remember that protons don't change, because protons, remember, for a few reasons. One, they're packed inside tight in the nucleus, and protons are what identify the element. All right, and then there's two types of ions. We talked about this in the last one. There's a cation. Once again, if you like cats, that's positive. It's a tough one. Cats are the worst. No offense, cat people, but you're the worst. No, I'm just kidding. An anion is a negative ion. All right. Common compounds are made with the gain or loss, by the loss and gain of just one electron. Sodium chloride, table salt. Sodium fluoride, it's an ingredient in toothpaste. Potassium iodide, it's an iodine salt. All right, and we'll go through some of this here. So potassium K, has one electron in its outer shell. Right. If potassium can lose that one electron in its fourth level, the third level is filled with 8. I'll scroll down. I think I got a picture. We got a picture of this down here. All right. And so if potassium can lose that one electron, it'll become positively charged. It'll become a cation because it has one less electron than it does protons. It would have 19 protons and 18 electrons. And so we would write it, it would become a positive charge, and so we would write it with a superscript. This is not really that good, so let me get it would look like this. K with a superscript. All right. And like some of the elements in group 2, they have 2 electrons in their outer shell. If they lose 2 electrons, like magnesium, for example, magnesium is in group 2. It's got 2 in its outer shell. If it loses 2, then it would have 2 more protons than it would electrons. So its charge would become, it would have 2 more positive charges than negative charges. All right, and so that's how you write a charge. All right, it's that superscript. All right, you write it as a superscript. It's the charge indicator of what the charge has become once it's become stable. All right, so magnesium would be 2 plus, potassium would be 1 plus, and we're probably not going to go much beyond the first 2 levels, or the first 2 groups. All right, an iodine atom. Let's say we're taking potassium and iodine. We're going to look at that. It has 7 electrons in its outer shell. It needs to get to 8. Remember that octet rule. The octet rule. 8. 8 electrons, what we want to get to. 8 electrons is what we want to get to. 8 electrons, what we want to get to. I feel like I can make a song out of that. So iodine would become no longer neutral if it gained an electron. So once again, it would be written as a superscript. You don't have to write the 1 there. You don't want to. No, you don't have to. If you want, that's fine. And then say oxygen, for example. Let's go with oxygen. So oxygen has 6 in its outer shell. It needs 2 more in order to have a full outer shell. So if it gained 2 electrons, all right, it would have 2 more negative charges than it would positive charges. All right, so that's how you write the charges. Once again, it's that superscript. Superscript. All right, and so here's basically what the 2 shell models look like. It looks really confusing, looks like a lot. That's why I like using dot diagrams. because it's like, whoa, we got a lot of electrons going. We don't care about any of the stuff on the inside. We only want to concern ourselves with outer shell electrons. Potassium's in group 1, so it's got 1 electron in its outer shell. Iodine's in group 17. It has 7 in its outer shell. They're a match made in heaven. So basically what's happening, and there's a science behind it. There's like the I don't know if it's affinity or electronegativity, whatever, where they're going to, iodine is going to really want to pull on electrons. It's going to have a stronger force trying to attract 1 extra electron, whereas potassium is not going to have a very strong hold on that electron. It's not going to want to pull on that electron very much. It's going to be willing to lose it because then it has this third level is full. It's got 8. 1, 2, 3, 4, 5, 6, 7, 8. And so if something comes around and takes that electron, that's good news for potassium because it has a full outer shell. So iodine, when potassium and iodine come in contact, the iodine is going to pull that electron away. It's going to steal it from potassium, and potassium's like, I didn't want it anyway. Joke's on you. And so potassium then will become positively charged because it now has, once again, 19 protons. It has more protons than electrons. It has a positive 1 charge. Iodine has a negative 1 charge. Because remember, it's gaining a negative charge. And so, but that's not the bond that takes place just because they transfer. The bond is when those unlike charges then attract. All right, it's when opposite charges attract. The positive will attract to the negative, and those unlike charges are going to attract each other. All right, so the positive potassium atom is going to be drawn to the negative iodine atom, and they're going to attract each other, and they're going to form a bond. All right, between them. The resulting compound has a neutral charge. All right, and that's important to know also. When ions form a bond, the resulting compound, anytime we talk about a bond, has a neutral charge. And there's going to be exceptions to this when you get into chemistry. It'll be like polyatomic ions and all that stuff. We're not going to get into that. But because a positive charge is bonding with a negative charge, this has a positive 1, this has a negative 1. When they bond together, it's the overall compound is neutral. All right, and you'll have to know that. So when atoms form a bond, the overall compound is neutral. So an ionic bond, just to recap, is the force, well, that's not what I wanted, sorry, is the force of attraction between the opposite charges of ions in an ionic compound. A transfer of electrons takes place. 1 or more elements gain electrons, while the other one is losing it. All right, and here's another example. Like so here now, what if we have, you might say, well, what if magnesium, an element in group 2, magnesium wants to bond with chlorine? Well, magnesium's got 2 in its outer shell, all right, just like we have here. All right? And so chlorine, this is already drawn. I don't know why I'm redrawing it. I just like drawing. All right, so chlorine can only fit in 1. So magnesium's like, well, that doesn't really work. I don't have a full outer shell. Hey, chlorine, get one of your buddies. Come on over. So then chlorine's like, all right. So chlorine then is going to have one of his buddies come over. I don't know why he's so much smaller. Don't judge me. All right, and then magnesium then can get rid of its other electrons. So when magnesium and chlorine bond, it takes a 2-to-1 ratio for magnesium. It takes a 2 chlorine to bond with 1 magnesium. And the reason why that is because magnesium has 2 to give up, but each chlorine atom only can take in 1 in order to have a full outer shell. And so if when magnesium chloride is created, the formula is MgCl2. All right, and the reason why it's 2, once again, is because magnesium's got 2 in its outer shell to give up, but a chlorine atom can only take in 1 because it's got 7 in its outer shell. Chlorine's in group 17. It's got 7 in its outer shell. So magnesium, in order for magnesium to bond with chlorine, the ratio from magnesium to chlorine atoms is 1 magnesium for every 2 chlorine atoms. All right. And so that's any element in group 2 bonding with a element in group 17, that's going to be the ratio. It's going to be 1 to 2 like that. Because all elements in group 2, I could have put calcium there. I could have put, whatever, beryllium there. Doesn't matter. Any element in group 2 bonding with an element in group 17, it's going to be a 1-to-2 ratio like that. But once again, the overall charge is the same because the magnesium becomes +2, but you have 2 -1 charges, all right, with chlorine. So the overall charge is still neutral. All right, once again, zero. The result of the bond, it's still neutral. It's a neutral compound. All right. We don't want any of our things to have a neutral. All right. So once again, that's the whole point behind bonding. And, oh yeah, and here's another key point that I wanted to go over. Ionic bonds always are going to form between metals and nonmetals. All right, because I'm going to ask you, I'm going to say, well, what type of bond is this? All right, and I'm just going to give you a formula. I'll give you magnesium chloride. And you're going to have to know that magnesium and chlorine, magnesium, where's it at? Oh, it's on the far left-hand side. Remember, most of the periodic table is metals. If you go from one side of the periodic table to the other, it's going to be, unless you're dealing with hydrogen, it's going to be an ionic bond because you're dealing with metals bonding with nonmetals. All your nonmetals are on, here. I forgot I just pulled up a periodic table. All your metals, can I draw on this? All your metals are here. All right. Now, these are all our metals, our alkali earth metals. So if we're bonding from one side of the periodic table to the other side of the periodic table, find the 2 elements that are involved, it's going to be an ionic bond because it's a metal bonding with a nonmetal. These are our nonmetals over here. All right, this whole group, nonmetal. We have some metalloids in here too. All right, the only exception to this rule, is hydrogen. Hydrogen is a nonmetal, and like H2O, H2O and hydrogen and oxygen bond, that's actually called a covalent bond because it's a bond between 2 nonmetals. So we'll get into that in the next video.